Welcome to a second look systems. Today we're going to look at how to solve a system of equations. 3 different ways. Graphically is first. So there are 3 types of systems of equations. One would be where you got one solution. That means you're going to get a point, an x and a y. So the way you would graph this is you always start with the y-intercept. That is the start. So place a dot on 2. The slope tells you the directions. So from your starting point of 2, this says go up 1 and to the right 2 and continue the pattern. You can also go down 1 and to the left 2 to continue the pattern on the other side. Then draw your line. The second equation starts at 8. Put a dot on 8. This tells us to go down 1 and to the right 2. I am heading in the right direction and I see one point where they intersect. This point of intersection is the answer to this system. That point is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6, 5. One solution. A system has the answer of no solution when lines are parallel. Yesterday we learned that parallel lines have the same slope but different y-intercepts. So let's graph them and see what parallel lines look like. The first equation we're going to start on -2. And we are going to go down 3 and over 1. Down 3 and over 1. We can also go in the opposite direction, up 3 and over 1. Up 3 and over 1. Draw your line. The second equation starts on +1. Put a dot on +1. And again, we're going to go down 3 and over 1. These lines will never cross. They are parallel. You can always pause the video if you would like to look at your notes to comprehend what's happening. The third type of system is infinitely many solutions. And this is actually when you solve for y, you get the same line. So this first equation, we start on 4. 1, 2, 3, 4. And we're going to go up 2 and over 1. Down 2 and over 1. And we're going to draw our line. The second equation is not solved for y. So we're going to add 2x to both sides. And we get y equals 2x plus 4. Notice these are the same line. So if I were to graph it, I would only have one line on my paper. If I only see one line, that is infinitely many solutions. So let's try a few problems. So let's solve each one of these systems by graphing. Remember, we start at the y-intercept, and this tells us these are the directions. So we start on +1. We're going to go up 3 and over 4. Up 3 and over 4. Again, we can go in the opposite direction, down 3 to the left 4. and draw our line. Second equation, we start at -4. And this tells us to go down 1 and over 2. And I realize I am moving in the wrong direction. So I'm going to go up 1 and to the left 2. And I can see where we are going to intersect. I like to circle that point. And that point is 1, 2, 3, 4, -4. 1, 2, -2. So this one has one solution. The solution is -4, -2. Example 2, we're going to start at -3. And we're going to go down 3 and over 2. Down 3 and over 2. We can go opposite, up 3 to the left 2. Draw your line. The second one starts at 1. It says go down 1 and to the right 2. And I'm moving away from the intersection, so I'm going to go the opposite way. Up 1 to the left. Up 1 and to the left. And I can see where I'm going to intersect. Right here. And that point is 1, 2, 3, 4, -4. 1, 2, 3. Remember, if your equation is in y equals mx plus b, like both of these examples, and you had a calculator, you could put them into your calculator. The first equation into y1, the second equation into y2. And to find the point of intersection, you hit graph, second, trace, number 5, and then enter 3 times. But practice a few on your practice page without the calculator. The next type of systems is by substitution. So this first example is solve for y, and that's when I would usually use substitution. So I'm going to replace y in the second equation with that whole expression. So I rewrite everything, 2x minus 3, and then I put in parentheses what y equals. Notice now my equation only has x's. I distribute. I combine like terms. And then I solve for x. I subtract 33 from both sides. -20x equals -40, and divide by -20. X equals 2. I am not finished because I need to figure out what y is. So I take x and I substitute it back up into here. And I get y equals 6 times 2 minus 11. So y equals 1. The answer is a point, 2, 1. Example 4. One of my equations is solved for a variable. It is solved for x, so I take this and I substitute it in for x. 2y plus 11 plus 2y equals 11. Combine like terms. 2y and 2y are 4y. Subtract 11 from both sides. 4y equals 0. And if you divide by 4, you get y equals 0. Y equals 0 does not mean that you don't have an answer. Y is 0. Put it up into the second equation and solve for x. So x equals 11. You have one solution. It's 0, 11. No, I'm sorry, backwards. 11, 0. Sorry. 11, 0. Question number 5. The first equation is solved for y. I'm going to place it into the second equation by substituting. 3 times negative 2x plus 6 minus x equals a negative 3. Distribute. 3 times negative 2x is negative 6x. 3 times 6 is 18. Minus x equals negative 3. Combine like terms. Negative 7x plus 18 equals negative 3. Subtract 18. Negative 7x equals negative 21. And then divide by negative 7. X equals 3. Substitute back up in for y. Y equals negative 2 times 3 plus 6. Y equals 0. Your answer would be 3, 0. Remember, at any point, you can pause the video. The last type of systems is by elimination. You would use elimination if you can notice opposites. So right here, I have a 4 and a negative 4. And then when you add them together, they make 0. You're looking for things like that. I can eliminate one of the variables. I eliminated x. So I'm just going to add straight down. The first part is 0. The second part is 6y. And the third part is negative 36. Now just solve for y. By dividing by 6, y equals negative 6. The hard part about this is determining which equation you want to substitute y back into. I like to use the one that has more positives, so I'm going to substitute it into that one. But it does not matter. And I need to solve for x. So 4x plus 8 times the negative 6 equals negative 24. 4x minus 48 equals negative 24. Add 48. 4x equals 24. Divide by 4. X equals 6. So the solution would be 6, negative 6. Question 7. Notice that I have the x's are the same, but they're opposite sign. They're the same sign. So what I need to do is, it's almost like I'm going to multiply this whole second equation by a negative 1, and that means I'm going to change all of the signs. So that becomes a negative 3, that becomes a negative 4, and that becomes a negative 17. And then I'm going to add going down. So the x's eliminate. They become 0. Y plus a negative 4y is a negative 3y. And 11 minus 17 is a negative 6. Divide by negative 3. Y equals 2. Pick one of your equations. I'm actually going to pick the first one because y is by itself there. So I get 3x plus 2 equals 11. Subtract 2. 3x equals 9. Divide by 3. X equals 3. So the solution is 3, 2. Question number 8. I don't see any where I could just add or subtract going down, but I do notice that right here is a 3 and this is a 1. So I can multiply this one by a -3 to eliminate the y's. I'm going to write it right underneath. So you would do -7x plus y equals -19, and you're going to multiply the whole thing by a -3 to get 21x minus 3y equals 57. And then your second equation is -2x plus 3y equals a -19. You can just add them. You get 19x, the y's eliminate, equal 38. Divide by 19, x equals 2. Substitute into the original equation. So I'm going to substitute it into the original equation. So -7 times 2 plus y equals -19. -14 plus y equals -19. Add 14 to both sides. Y equals -5. So your point is 2, -5. When you are done with the video, come up and get your practice problems and try a few on your own.